Tessellation is coming under the architectural concept of mathematics. So mathematics is not only about equations, graphs, and the mean, median, and average, and statistics, physics. Not only them. Architecture. When you think about a building, there also we applied mathematics. That kind of an application is here. In tablecloth, we have some kind of patterns. That is also constructed by using some mathematical principles. That is the simplest example I can explain. That is our tessellation. But actually, the mathematical explanation is a certain space using one or more spaces in a repeated pattern without gaps and without overlaps is called tessellation. Not always, but in our dress we can see some kind of overlaps. Okay, here there is a circle, over that there is a square, and there is a triangle over that. This is not considered as a tessellation. So there are some conditions in the tessellation also. In the tessellation, we can construct a tessellation by using a same shape. For an example, a square. It will give you a kind of tessellation. Single shape. This is called as pure tessellation. If you use only a single shape to construct a tessellation, that's called as pure tessellation. You use more than one shape, more than one or two shapes. I will use a triangle and a rhombus, and a triangle and a rhombus, triangle and a rhombus. This is called as semi-pure tessellation because it consists of more than a single shape. No, obviously we can see here all are identical blocks of squares. So that is pure tessellation. Here we can see these are identical triangles, but these are identical rhombus. These two are not same. This is triangle, this is rhombus. Those are two different shapes that will create semi-pure tessellation. And there should be no any gaps between these shapes. Okay. For an example, here there is a square and here there is a rectangle. Like this, when you draw something like this, triangle, rectangle, here there is a gap. No, there is a gap between these shapes. This cannot be considered as a tessellation. This is an exception. These are not coming under tessellation. Those are patterns but not tessellations. Without overlapping and without gaps, if the shapes are arranged, that's called as tessellation. Without overlapping means I have a triangle here. Over the triangle, I'll use these shapes. I have a rectangle here. Over the rectangle, I am going to draw a rhombus. And again, I am going to draw one more rhombus here. Okay, here you can see, even though it looks like a pattern, but overlapping happened, no? So these are also cannot be coming under tessellation. These are some kind of patterns but not coming under tessellation. Without gaps and without overlaps, the shapes are arranged in a manner. If it consists of a single shape, pure tessellation. More than a single shape, semi-pure tessellation. In pure tessellation, only one shape. But in semi-pure tessellation, there is no any restriction. More than one means it can be 2 shapes, 3 shapes, 5 shapes, 10 shapes, like there are many. So here I use the name shapes. Actually, the shape should be 2-dimensional shapes. No, we can't use 3-dimensional objects in the tessellation. It has to be 2-dimensional. In a plane, we can draw rectilinear planar figures. So rectilinear planar figures is not that difficult, that's simple. A square, a rectangle, a rhombus, a pentagon, a hexagon. Okay, these kind of rectilinear planar figures are created by using some number of straight lines, not circle, not oval, not some wavy shapes like this. Only you have to use straight lines to create an object that's called as rectilinear planar figure. Here the shape which we need to use in the tessellation, it has to be a rectilinear planar figure. What is rectilinear planar figure? It should be created by using only straight lines. 3 straight lines together, triangle, 4 straight lines together, rectangle, rhombus, or else star, many. A quadrilateral or else a trapezium, pentagon, like these are the shapes called as rectilinear planar figures. In tessellation, we are using this rectilinear planar figure. Why we are not using circles? Because when you draw a circle here, I'll raise and explain. When you draw a circle here, definitely there should be a gap or else there has to be an overlap. Here there is a circle, there is a circle, there is a circle, there is a circle. Definitely we can see there is a gap happen here. No? But in the tessellation, there has to be no any gaps. So that is not coming under tessellation. So that's why we are using rectilinear planar figures only.